CBE 302, Syllabus, January 4th, 2004. Dr. Sankar V. Raghavan is the instructor. His email is given. His phone number is given. CBE 320, Spring 2022, Chemical and Biomolecular Engineering Laboratory. Textbooks, Writing Style and Standards in Undergraduate Reports by Sheldon Jeter and Jeffrey Donnell, Georgia Tech, College Publishing 2003, 309 Linwood Drive, and it's available at www.collegepublishing.us. Also, the second one is in Transport Processes and Separation Principles, 4th edition. The objectives of this course, CBE 302, the laboratory. The Chemical Engineering Laboratory is intended to accomplish the following goals. 1. To develop technical communication abilities through formally written reports and oral reports. 2. To cultivate interpersonal working skills as team members. 3. To provide practical experience in using equipment, analyzing data, and understanding experimental errors. 4. For the selected experiments, develop an in-depth understanding of the describing operation. Also, for mandatory course material, you would need a bound laboratory notebook, numbered and one per team. 2. A pair of safety glasses. Also, course organization. The class will be organized into groups of 3 or 4 students in the first 2 classes. In industry, employees seldom get the opportunity to choose their teammates. In alignment with this practice, the instructor will assign members to each team randomly. Accommodation will be made for personal factors such as working outside of class and forming the teams. More details will be communicated during the first class. Each team will perform 5 experiments by rotation as shown in the laboratory schedule sheet on Canvas. The 5 experiments, Table 1, cover topics that you learned in other CBE courses. Each laboratory project will be conducted with guidance from the instructor and teaching assistants. Table 1, the laboratory projects. We have experiment, subject matter, and new topic. We have 5 examples. So pack bed reactor, we have distillation, we have shell and tube heat exchanger, pipe flow and centrifugal pump operation. We have bioreactor. For the subject matter, we have reaction engineering and mass transfer solution thermodynamics, and heat transfer and momentum transfer application of the Bernoulli equation, and gas-liquid mass transfer. Also, there's new topics for the distillation. The second one, we have multi-stage equilibrium, we have experimental design, we have dimensional analysis employing the Buckingham Pi method. Moving on, the experiments are designed to show practical applications of topics you learned in your chemical engineering classes. More instructions in the form of either class notes or Zoom videos have been supplied for each topic. In earlier offerings of this course, students had difficulty connecting their lab exercises to things they had learned in earlier classes. To close this gap, the course requires students to respond to a quiz on each of the experiments. The steps to be followed in completing an experiment are 1 through 9. 1. Name a project leader for the first 4 experiments. Each student should assume this role at least once, selected by alphabetical order of the last names. The leader is responsible for assigning individual tasks and overall coordination. The leader is also responsible for writing the abstract and the summary and conclusion sections for the experiment. 2. Prior to performing an experiment, A. Each student should examine the physical setup of the experiment with the TA, the teacher's assistant. B. Review the literature. The primary source of information are the Zoom videos, instruction manuals, the textbooks by Jen Kapolis and Folger, and the relevant portions in the vendor equipment manual. The vendor manual has a wide range of assorted information. Refer to the instructions for each experiment for chapters in the equipment manual that you should review. C. Each student should individually respond to the quiz on the experiment 4 days ahead. 3. Each group should submit their plans for the experiment 3 days ahead. The planning report should clearly elaborate on the experimental procedure, observations, and the data you plan. 4. The lab experiment should be performed on the date assigned to your group on the lab schedule. Students are expected to show proficiency with the theoretical and experimental aspects when performing the experiment. They also should abide by the rules for safety and laboratory etiquette. 5. An interim report is due 5 days after performing the experiment. The interim report should answer the questions listed in the interim report section of the lab manual. 6. If the interim report shows that some observations have been missed or unreasonable, the affected group can ask that they be allowed to redo the experiment in the following week. A group will be granted this permission no more than twice. 7. Written reports are due 2 weeks after the lab is performed. 8. Oral report on project number 5 is presented as scheduled in the laboratory schedule. 9. Rewrites may be allowed under exceptional circumstances. Supplemental information. Time management and meeting your individual commitments on time are essential in a team environment. In this regard, attendance to all scheduled classes, laboratory sessions, and oral presentations of the group work is highly recommended. Student teams should at once set up what is expected from each team member, when the team will meet, how the team will work, etc. Any problems within a team are to be discussed with the instructor as soon as the difficulties arise for resolution early in the semester. This includes such things as a member not taking part in the experiment or not helping in the analysis of data. Every team member is to be involved in and responsible for all aspects of the report. It was mentioned that the leader of a project handles the abstract and summary and conclusion sections. This does not mean that other team members are not responsible for these sections. They should review and agree with the input by the leader. The use of computers by engineers to prepare reports and documents is standard today. This includes equations, figures, and tables. Photocopy material in reports is discouraged and may require a copyright release. Do not use any photocopied material in your reports without first discussing it with your instructor. This does not apply to any scanned copy of the original data, which should be placed in the appendix. A major step in preparing high-quality reports is to carefully proofread and review your document. This is best done by putting your report aside for a few days and then giving it the final upgrade. Every member of the team is responsible for the entire report. That is, every member should read the whole report to see that it satisfies the writing guidelines. It is up to your standards, you understand the entire content, and know how the calculations were performed. You might also get someone else to critique it for you. All laboratory and data observations are to be made in your bound journal or computer. The taking of data on loose paper is unacceptable. To continue, the supply continuity say that you are noting the data in a computer. The data should be recorded with sufficient information that includes units. The gold standard is a technically proficient person should be able to understand your notes. It is most important to recall all your runs, bad runs and good runs. Experiments in which all the activities go ahead smoothly are rare. One should make the distinction between discarding runs which do not fit the theory and discarding runs which are faulty to the identifiable experimental difficulties. Disregarding runs for the first reason violates one's scientific integrity, while disregarding them for the second reason is quite usual and proper. Laboratory journals. The lab journal for each team is to be brought to all your laboratory team meetings and all the instructor meetings. Before leaving the lab after an experiment has been performed, each member is to read the team journal. Once you understand the work in your team's journal, write the phrase read and understood pages X to Y at the end of the entries, and then sign a date. Note, the journals are signed by all team members at the end of a lab project. The journal should be signed and dated by the teaching assistant prior to leaving the laboratory. For the first entry in your team journal, collect the names and phone numbers of your team members, review the schedules, and decide when you will be able to have the team meetings, along with the planned project leader for every laboratory project. Planning report. Planning an experiment is important. Before any experiment is performed in industry, the data to be taken, time needed, data analysis, and approximate cost and results are evaluated. To enforce this practice in your projects, as well as becoming familiar with the equipment, each team is responsible for preparing the laboratory by reading the lab manual and any suggested reading. Further, each team will examine the experimental setup a week before the date of the laboratory and discuss any questions they may have with either the TA or the instructor. The students should probe the design assumptions, the required data to respond to the goal of the experiment, and the potential pitfalls when planning an experiment. Not all the minute details related to the experiment are explicitly told in the instruction manuals. However, the highlighted words in the planning section of the instructions to each experiment and answering the questions for the quiz should help, as they should alert you to how, what, and when for details that should be addressed. Each group should submit a pre-lab report 3 days before the date of the experiment. The planning report should not exceed 7 pages. At the end of the report, each student should write a brief paragraph describing his or her contribution. Lab experiment. The lab notebook should serve as a repository for the data you collect for each experiment. Start on a fresh page, summarize the experiment's goals, and note your observation in the lab notebook in a chronological manner collected. If you are noting the data in your computer, write it down in the proper location, cross out incorrect data, and do not use whiteout. Your notebook should list both correct and bad outcomes. This is seldom that all the data you generate in an experiment is correct, so it is normal to find a cross out of information and data. The key requirement is that you supply enough information so that a person technically knowledgeable in your field can follow the lab notebook entries later. You should test this by asking one of your teammates to read your entries and check whether he or she follows the entries. After you have finished the lab and cleaned up your work area, this includes dusting and cleaning, read and sign the journals as described in the laboratory journal section. Finally, each team's journal is to be signed and dated by the graduate teaching assistant. Interim report. An interim report is due 5 days after performing the experiment and should answer the questions in the interim report section of the laboratory manual. The report affords an opportunity to analyze your experimental data quantitatively, evaluate the strength of your corrections, and reject outliers based on proper justification. The answers should be presented in graphical or tabular form, whenever possible, and should include sample calculations. The report should follow a bulleted format and should have a minimal amount of descriptive writing. The interim report should not exceed 7 pages. At the end of the report, each student should write a brief paragraph describing his or her contribution. Formal written reports. The first 4 projects are performed, analyzed, and written as a team. The team turns in a single report, suggested length about 12 pages for the body of the report, plus 8 pages in the appendices. Detailed guidelines for preparing reports are provided in the textbook. Written reports are due 2 weeks after the lab session. The final report should be written in the format of a long report from JETR 2003. It should address each aim, including the ones that are not highlighted, of an experiment and supply recommendations for future improvements. More instructions about the final report will be provided in class. The body of the final report should not exceed 12 pages. The total number of pages in the appendices should be less than 8. At the end of the report, each student should write a brief paragraph describing his or her contribution. The oral report. The same procedures are to be used for the last project, except the report is presented by the team as a 15-minute oral presentation. The presentation is followed by a 10-minute question and answer period. More details on the material needed for those reports will be provided. The oral report on Project 5 is presented only to the instructor and your GTAs and members of the faculty. The details will be clarified as we approach the presentation phase. A hard copy of the presentation slides, calculations, and spreadsheets are due as usual. A short meeting may be arranged with your instructor to look at your presentation material before your scheduled presentation. Communication with the instructor. Communication with the instructor outside of planned meetings is to be done as much as possible via email on Zoom. The other choice is to meet with me during my Zoom personal room during the office hours from Tuesday through Friday, 9 a.m. through noon. Just email me that you are joining me in my room. The lab schedule. The schedule for the pre-lab report, the lab experiment, and the interim report, and the final report or presentation are listed in the Excel files in the schedule folder on Canvas. Grades. The overall class grade would be a sum of your group's performance and your individual contributions. Some of the grades are letter grades as shown. The letter grades may be used to adjust the final grades either up or down. Opportunities for earning extra credits are also available. The grading scheme for the course is shown in Table 2. Late report penalty. A late penalty of 2% may be made for each day a report is late. Unexcused absence. A penalty of 10 points may be imposed for each unexcused absence for the full duration of any class, group presentation, or experimental session. There will be no makeup arrangements except for truly extraordinary situations. Discuss any situation at once and directly with the instructor as soon as it is known. This is from Dr. Sankar V. Raghaven.